I will be presenting the software. It's called the Winding Expert. The software is also catalog protected, so you have to have this catalog key on the computer all the time. So don't take this key out. I'll also give you another one, so you have it as a reserve.
The key, the hard key.
Okay? The hard key. Yes. So this is the starting view of the Winding Expert, in which you can see you can either start a new project or open an existing project, see some manual stuff. We'll now start by creating a new project. Okay. As you can see, you can create a new project by using a mantra. So you can either load the mantra if you have one on the disk, or you can create a mantra. So now we're going to create a mantra. So what's a mantra? This is a mantra. A symmetrical unit that is being placed on the x-axis as a protease. So I need a meter now, so we can measure the dimensions of the mandrel and enter them here. Okay. We're going to measure the length of the mandrel, 700 millimeters. This 700 millimeters is the total length of the mandrel. It's total. We want to use two types of length. We call something just the length, cylinder length, and the other type of length we call extension. So out of these 700 millimeters, we say I want the extension to be 50 millimeters from the one end, 50 millimeters to the other end. So that's 50 and 50, 100. So you, how do you say, from the 700 you minus
50.
minus 100 is 600. So you get the length of 600 and extensions 50 and 50. So this is what we will enter here. And I come closer, please, and see. So cylinder length 600, extension 50 each side. And the third parameter we need to enter is the diameter. So we enter the diameter. So now we have all the parameters that we need, and we can save the mandrel and start working with the project.
So the 600 is the actual length you want to work on.
Yes, I'll tell you what's the meaning of this length and the length of the extension. So we create a new folder, training. File name, tube mandrel. You give a descriptive name, one which you will easily recognize. So this is the main view of the Winding Expert. As you can see, we have three windows. The first window is an OpenGL representation of our mandrel. Full with zoom and 3D view rotation. And this cube is for orientation purpose. With this first button here, I always place it in the original position. From front to back. This part here, the right part is the right part of the mandrel.
The first box.
Yes. So next we have another window. This is called the parameter window. This is where we enter the parameters we need so that we can create a segment, a layer. So these two words are synonyms, a segment or a layer. It's a segment of a composite material. Let's choose the helical one. And we'll leave the original speed of 35 meters per minute. This is the speed for the fiber speed. This is the bandwidth of 15 millimeters. We'll leave it there. And the winding angle by default is 57. Let's leave it 57. Yes. So now we leave the original values.
What is the bandwidth again?
Bandwidth when you have many fibers. And the length of the width of those fibers. Those fibers, they form a kind of a band. You see this is 10 fibers. And this is actually a band. So you measure from here to there and you have a bandwidth, the width of the band. This is where I select the direction, positive or negative. So if you start from this point here, it's a positive direction of the winding. If you start from the back, it's a negative. So by default, it's positive. Here we have time of the cycle and of the layer is 0 because we have not created any layer yet. So now to create a layer, we click calculate button. And it will work for a couple of seconds.
You come to bandwidth. If you have two fiber, you put bandwidth of 15, so there's space.
Two fiber probably 6-7 millimeters.
So they are spaced apart to form the 6 millimeter width.
So there are two fibers like that,
Yeah.
and I think that the total weight of the two fibers will be maybe 6 millimeters.
Okay, they are
That's my
spaced.
assumption.
Okay.
If you use fiberglass, if you use maybe Kevlar, it will be 3 millimeters with Kevlar.
Okay, so you space them apart. When you wind, you are spacing the two fiber apart. And that's-
Apart?
Yeah,
No, that they are together.
together.
Yes, they're together acting as one. If you have 5 fibers, they're acting as a band, as one band. They will never be apart. They will be together. If you have 2, they will act like one. If you have 10, they will act like one band.
Okay.
You will see. So now we have the winding expert created several patterns. So when you want to create a composite segment or layer, you have a choice how to create it, and we have several patterns. And those patterns are explained with these numbers here. The first number is the ordering number, 1, 2, 3, 4, 5. You know the number of the pattern. The second number, this is there are two numbers actually. They give description of the pattern. Say 1 cross how this slash 1/0 pattern. The other is -1/0. Then we have -1/1. Okay. I'll give explanation to those patterns as well. But for the moment, we will choose the -1/1 pattern. The third number is the number of cycles. So to finish this layer, you will need 18 cycles. What is a cycle? One cycle is when this carries axis starts from here, goes to this position to the end, and goes back to the original, the first position. This is called one cycle. So we will need to repeat that 18 times so that the whole mantle will be completed with a composite material. And the fourth number is the covering in percent. So what is covering? You have, let's say, a band of 4 fibers. Okay, so the fiber is placed like this by some angle. We chose the angle of 57, right? Probably this is 57. So the next time, the next cycle, the fiber comes in, it's placed right next to the first fiber. If it's right next to the first fiber and there is no gap, no overlap, the covering is 100. So if there is little gap, the covering is less than 100. And the percentage gives you an idea of the right amount of the gap. So 90% covering will be like this, 80 like that, 70, 50, you know, the gap will increase. And if you go over 100, there will be overlap, like 100, 500, 10, 120, 200.
Bandwidth.
Yes, bandwidth. Sometimes you need gap, sometimes you need overlap. This is where you can monitor the actual value of the covering. So now let's have a look how the winding of the composite material will look. We have a simulation in our 3D view window. We choose the pattern -1/1 and we stop it. Here, by using these buttons, I can stop it at the half cycle. It comes here and I stop it, so now I will continue. So you see, now I have one cycle. This is how the mandrel will look after one cycle of winding. So now I continue it. 1.5 cycle. 2 cycles. And we can let it continue by itself. Here, in this scroll, we can increase or decrease the speed. Now I have decreased it to the minimum speed of winding of the simulation. This is the speed of the simulation only. So now, all the 18 cycles have been finished. And this is how graphical simulation of what the mandrel should look like using these parameters and this pattern.
So it's all calculated for you.
Yes.
Guarantee 18 cycle you cover everything.
If you enter the correct parameters here, you should get this result. So what do I do now? Because I have seen what this looks like, I say, okay, I like it. Then I have a look, view here, view the G-code. So this is the G-code of the winding. And we're going to edit the segment to our project. So now I edit this helical 57. Okay, enter. It says the segment has been added to the project. So now here, you can view this segment. This window here is called the project window. It contains all our segment files. So this project now consists of only one segment. It is called Helical 57. The segment files, they have the extension FWS. That's filament winding segment. We have in Microsoft Running Expert 4 types of file. One we use for the mandrel, we call MDR. It's extension for mandrel, MDR mandrel file. FWS filament winding segment. Also we have the WP, that means filament winding project. And also we have the NNC. This is the end file with the G code. It stands for Microsoft NC code. And this is the final result, final file that comes out of the expert. You know, that's the file that contains the G code. And in order to, let's say we want to get the G code for this project, all we have to do is save the project. So we go to project, save, and you name, so project Helical 57. Oh, all capital letters, okay, no problem. Project Helical 57. And there we go, now we can save it. Now we can go in the Explorer, using the Windows Explorer. I'll just fill the address. Here we are. We can view the 4 files that are used in one single project. The first one is the segment file, the FWS. The second file is, you can see it here, the type, FWP, project file. The MNC, the G code, and the MDR is the mantra file. All of these files, they are text files. So you can open them with Notepad editor. So I want to show you the G code file now. Okay, this is the G code file. The G code file consists of information about itself, that it's project file, which project file does it do, the G code for building, binding, some machine and stuff. And then it has about 10 lines of information about what segment files we will be using and whether we want to use starting point and some other features. I will explain the other features later. And then there's the G code itself. Once you create the G code file, then you can actually close the expert, and then you can open the Winding Commander. With the Winding Commander, you load the G code file, and the machine starts working. It starts winding this project. Okay. Any questions for this part? So, what I basically told you now is how to work with the expert. You have several steps. You load a mandro, create a mandro. Then you enter the parameters for the layer, like speed, width, like angle, direction, and then you calculate it. Then the expert gives you a choice of patterns. Then you choose one pattern. Then you see it here in the simulation window. If you like it, you save it in the view button, add segment, you add it to your project. So those are the steps of creating one project. So, I'll step into detailed explanation of the expert now. Okay, we can have a look at these time controls. It says 6:69 seconds, 2 minutes. This information gives us time about cycle time, 6 seconds, layer time, 2 minutes. Okay, so one cycle 6.6 seconds, multiply by 18 cycles gives you 2 minutes. This is 2 minutes of execution time. Okay, next. I'll explain you about the winding angle. This is the winding angle, 57 degrees. Let's change it now. Let's create one of, let's say, 68 degrees. If we change some of these values, the patterns automatically disappear because we have entered another parameter and the old patterns are no longer valid. We have to recalculate the patterns again.
Angle is with reference to this horizontal.
Sorry?
The angle? Why is
Yes, with this. Yes. So now you see, remember it's something like that, and now we change it. It's 66. This is even higher. That's it. Let's change it to let's say 76. Choose a button. And come on. This is the angle at the middle point, at the center point of the mandrel. So right here somewhere. And to the horizontal. So,
The cycle is automatically calculated.
yes, everything.
This bandwidth is determined by our stock.
Okay,
fiber, right?
this is how we determine the bandwidth. We place the fibers up to the eye, bring it to the starting position, connect the fiber to the mandrel, tape it or stick it with something so that it won't slip. Then make one cycle with the machine, with with the desired angle. Say it's like to create a project 66, you make one cycle of trial with the 66 degrees. Then you measure the bandwidth of the actual fiber, because nobody can calculate the actual fiber, the bandwidth, but the bandwidth itself on the mandrel. Nobody knows how it will spread.
So that means we have to
Yes,
run
because the other software they tell you enter how many fibers and it will calculate. It's not impossible. Only real measurement can tell you what's the bandwidth.
So we need to do one trial
One
run,
cycle, yes, you see
measure the
everything.
actual bandwidth.
Yes, because the first cycle will always tell you how many mistakes you made. You will probably make mistakes with the starting point, with the